Welcome back, everybody. So if you're playing along at home, which I've got a lot of people out today, shout out everybody in second period that's not here today. Shout out Dalton. Dalton, if you're watching, hey.
No. Football in the back of the head.
He's not watching. Sid thinks you're not watching. Sid thinks let's do something here. Hey, everybody that's out today, if you're watching the video, I need you to come up to me on Monday when you see me on Monday and tell me the code word. The code word is bananas. If you walk up to me on Monday and say bananas, I know you had watched the video.
What if we walk up to you and we were here and we say banana?
Okay, now everybody in class, you can't say anything.
But like Mr. Laverick, you're gonna be disappointed because they're not gonna know.
Somebody's gonna know. Somebody's gonna walk up to me and say, Mr. Laverick, bananas. And I'm gonna be like, proud of you.
You should do that every video to see if they watch.
You know what? I bet it's gonna be Kyle. I think Kyle's gonna watch the video. I think he is.
I miss you, Kyle.
Hey, look at my dog. All right. So let's get back to math here. If you are playing along at home, here's the warm up. You can pause, do it. I'll go over it in a minute after I go through the homework. So what questions I know we're going to have to go through a lot of these. That's okay. Nathan.
Can we do number 7, please?
Yes. So let's first start by going over number 7. So first thing, locate the variable that you're trying to find. So we're trying to solve for. So I've got B here. Now, second thing, identify the operations being done to that variable. I am adding to A, and I'm multiplying by the 2 that's next to that B. Remember that we do reverse order of operations, so I need to do the addition. I get rid of the addition first. To get rid of the addition, I do subtraction.
Teachers, please excuse this interruption.
Fire Joe, please.
As we reflect on the events that occurred beginning at 8:46 a.m. on September 11th, 20 years ago, I would like all staff and students to join me at this time in a moment of silence as we remember those who lost their lives on September 11th, 2001. While we pay tribute to those brave men and women who did not survive that infamous day of 2001, let us also take a moment to pay tribute to the thousands of men and women who are still practicing or still protecting and serving us in the military, as well as all first responders and those who have dedicated their lives as members of our fire and police forces. I would suggest that the best way to honor their memory might be to take a moment or two today and every day to do an act of kindness for someone who crosses your path. Have a great day.
You too, Mr. Howe. All right, so let's get back to this real quick. So this is C minus 2A. Now I know that I've got to get B completely alone, so that 2 has to go away. Meaning I've got to divide it over to the other side. And each piece gets divided by 2, which is, as I was walking around, that was another thing that I saw not happening. Each piece needs to get divided by 2. If you have multiple terms on the other side, each term needs to get divided. Sorry, that's just the rules. So B is equal to C over 2 minus. Now, do you see this 2 over 2? That can cancel, leaving just an A. So B is equal to C over 2 minus A. B is completely alone. There's my answer. Yeah. Any other questions on 7? Okay, let's do the same thing for 10. Solve for x. Now, I see 2 things happening to x. It's multiplied by -3, and then subtracted by 12y. So reverse order of operations. I got to undo my addition and subtraction first, so that minus 12y needs to go over to the other side by adding 12y to both sides. So negative 3x is equal to 18 plus 12y. Now I can divide. Now I divide by negative 3. And remember, do you see the two terms on the right side? Both of those terms need to get divided by that negative 3. Negative 3 here, negative 3 here. So x is equal to 18 divided by negative 3 is negative 6. 12 divided by negative 3 is negative 4. Negative 6 minus 4y. Each piece gets divided by negative 3. And you try to either reduce the fraction, or actually these ones actually divided both by 3. If they're not easily divisible, if they're not, if it's not divisible by the number that you're dividing by, then you just leave it as a fraction. You got to reduce that fraction, but you leave it as a fraction. Give me another one to go over. Danielle? Number 4 right here. All right, so again, I see two things happening to n. I see a 3 times n, and then the 3n plus 1. So I see the plus 1 and multiplying by 3. So that means I need to subtract a 1 first. Remember, do your addition and subtraction first. A minus 1 is equal to 3n. Now, this is a case where when I divide by 3, each piece needs to get divided by 3, but is there anything to reduce here? Like, is it like a 6 over 3 where it becomes 2? No. Is it like a 10 over or 12 over 3 where it becomes 4? No. And so this has to stay just a over 3 minus 1 over 3 is equal to n. You kind of like leave it as fraction form there. So a over 3 minus 1 over 3.
Would you accept the 1/3 in the decimal?
I wouldn't like that. No. What's that? Oh. Hold on. 9062. Oh. Oh, maybe that's not going to work right now. That's okay. Yeah, Solomon.
Is a minus 1 divided by 3 squared?
All divided by 3? In this case, I would accept that because nothing reduces. But if you had tried to do that on 10, where it was like 18 plus 12y all over negative 3, and just left that, I can't accept that. Questions? What else? Anything on the anything else on the worksheet? No? Okay, let's get to the warm-up then. I got 2 easier ones and then a more difficult one with the solve for p. So let's take the easy one here. If I want to solve for c, all I need to do is just divide by 4 over to the other side. So c is equal to d over 4. The second one here, n minus 6m is equal to 8. All I need to do is just add the 6m over to the other side. 8 plus 6m. The one operation ones are usually a little bit easier. It's the third one here that's a little bit more difficult. Take a look here. If I want to solve for p, I see 2 things happening to it. I see that it's multiplied by 2, but I've got to add 5r to it as well. So I subtract the 5r first. Subtract 5r over to the other side. So that's going to get me 2p is equal to q minus 5r. Everybody following me so far? I know it's still not working. I think it's working. So it's q minus 5r, right? Now, here's what I have to divide by 2. I have to wait until now to divide by 2. And everybody gets divided by 2. In this case, this is another case where it does not reduce. The q over 2 just has to be q over 2. The 5r over 2, does 5 over 2 reduce? I mean, technically, could we make it 2.5? I guess so, but I really wouldn't like that. Let's just leave it as 5r over 2. And that's my answer. All right, we're on day 2 of section 1.7. Just more of the same. It's nothing new, nothing different, same rules. Just more of the same. And based on the questions that were asked, it's more of the same that you guys were kind of struggling with too. Which is good. You need to practice that stuff. But again, I tell you, if you don't try on your homework, it's not going to happen. It's not going to work. You're not going to figure it out. Let me try one more time to get the board back up and running. Cannot connect to the receiver. I wonder if the IP address changed. 1024.126.44. 062. Yep, that worked. I don't know why. Okay. All right. So section 1.7, day 2. What you see here is another definition of, we had formulas, but also these things called literal equations. It's just another way to talk about these formulas, just another term that we can use. A literal equation is just basically one that only has abstract meaning, that only has just variables in it. We haven't put any real life context to it. It's just variables, okay, just variables. How do we solve it? We rewrite a literal equation, solve for one variable in terms of the other variables. So let's keep practicing. Let's keep practicing. Let's solve this first example for y. Let's solve example A for y. I want you to think in your head what the first step should be, and then I'm going to ask you about it. Okay, what do you think my first step should be? Noah?
To divide 3.
Nope. I don't want to divide by 3. Solomon? Subtract 4x. Good. Remember, reverse order of operations. So do your addition and subtraction first. Subtract 4x first. So that's going to get me 3y is equal to 9 minus 4x. Now I divide by 3. Same question? No. Now I divide by 3. Now, when I divide by 3, I have to be careful here. Each piece gets divided by 3 over on the other side. And I say I got to be careful because can I take 9 divided by 3? Yeah. That's just 3. Right. Now, can I reduce down this 4 over 3? I mean, somebody said last period, should we make it 1 1/3? I guess. But I like improper fractions rather than mixed numbers. Okay, so I would say let's keep it as -4/3. And again, I would like you to write it as the fraction instead of putting the x on the top. Would it be, honestly, could we write it with the x on the top? Yeah, we could. We could say y is equal to 3 minus 4x over 3. That's equivalent. That would be fine. I'm not going to like that soon enough because we want to put this into slope-intercept form, and the intercept or the slope would be that fraction in front of x. Right? But it's not wrong if you write it like that. Questions about A? Okay, let's take a look at the second one. 4x minus 7y is equal to 9. I want to solve that for y. Question? No. Oh, 1 second. Let's find y. I want everybody to think about what your first step would be. Just think about it. I want everybody to think about what the first step would be. 4x minus 7y is equal to 9. Okay, what do we think the first step is going to be? Nathan?
Add 7.
Not going to be to add 7. Because the 7 is being multiplied to the y. So to move it over to the other side, I would have to say division. Danielle? Subtract 4x first. Good. I want to subtract 4x to both sides. So that's going to get me a negative 7y is equal to 9 minus 4x. I got to move the term over before I start dividing. So now we can divide the negative 7 over to the other side. This divides by negative 7. Remember, both parts on the other side divide by negative 7. Now, 9/7. Does that reduce at all? No. I mean, I could make it 1 and 2/7, but I'm not going to make it a mixed number. But it's negative 9/7. I guess I can put the negative out front. That's the only thing that could possibly happen. But look here, negative divided by negative. Something does happen to the second piece here. Plus 4/7 x. That's my answer here. Negative 9/7 plus 4/7. Questions about that? Okay, I want you to try C on your own. All right, so first thing, I want to solve for y. So find y. What do I have to do first? What do I have to do first thing? Minus 2x, very good. Minus 2x. So we subtract 2x from both sides. So I've got 8 minus 2x on the right side. Now we divide by 6. Now, I would be very happy if you guys got to here. How do we do? But we can simplify this. There's actually one more step to do. Yeah, there's one more step. Can I simplify this fraction, 8/6?
4/3.
4/3. So y is equal to 4/3 minus, now 2/6. 1/3. That's truly my answer. Now, if you got to y is equal to 8/6 minus 2/6x, I'm happy for right now. By the time we get to the test, no. But for right now, I mean, it shows that you're doing the problem correct, but we just got to reduce our fractions. Okay, let's do one more of these. Let's do this last one together. 8x minus 4y is equal to 11. Again, solving for y. So I circle y, I get y alone. What's my first operation to get y alone?
Minus 8.
Minus 8x, good. Now bring down the negative 4y, and it's 11 minus 8x on the other side. The only tricky part to this one is that I'm dividing by the negative. Watch out for that. And then everybody gets divided by negative 4. So we get y is equal to negative 11/4. Now, does negative 11/4 reduce? No. I mean, I could call it 2 3/4, but I'm going to leave it as an improper fraction. And now, negative divided by negative is a positive. 8 divided by 4, 2. Negative 11/4 plus 2x. Hopefully we're feeling just a little bit better about those. But I got 2 more word problems that we want to talk about. The first one here. The formula C is equal to pi times diameter gives the circumference of a circle C in terms of its diameter. We're probably a little bit more familiar with c is equal to 2 pi r, but 2r is just b, right? 2 times the radius of diameter. So pi times diameter is the equation of a circumference. Now, the first thing it asks me to do is solve for d. I'm going to hold off on this second piece of the question. I'm going to answer the first part. C is equal to pi times d. What solves for d? How do I solve for d? Divide by pi. Okay, so let's do that. We divide by pi over to the other side. So c divided by pi is equal to our diameter. So basically what we just did, well, the statement that we just made is that you can solve for a diameter by taking its circumference and dividing by pi. You can take any circle's circumference, the distance around the circle, divided it by pi, the constant pi, it will get you your diameter. So now the second part of the question says, well, if the circumference of the bowl is 18 inches, what's its diameter? And I'm going to not, you could cross out that last part about leaving your answer in terms of pi. I'm going to give it as a decimal. If the circumference of the bowl is 18 inches, what is the bowl's diameter? Okay, circumference is 18 divided by pi. That's going to equal the diameter. And I'm going to suggest, and I'm going to strongly encourage you guys to, instead of using just 3.14, use the pi button that's in your calculators, because that's the unrounded option. 8 divided what? That's 2 pi. Divided by pi. 5.73 is our diameter. 5.73 inches. That's the bowl's diameter. So given the circumference of the bowl, I could find the bowl's diameter. Maybe I took a string, put it around the outside of the bowl, measured the circumference, and then I said, okay, I want to find the longest length across the bowl. Just divided by 3.14, and there's our diameter. Let's do one more problem. So this is an equation where we have the calculation for words per minute, like typing speed. This is the calculation for words per minute. So your calculating speed, or your typing speed, is equivalent to W, which is your words typed, minus 10 times your amount of errors that you have. So basically, when you get your words per minute, in that calculation, you're losing words per minute. You're going down based on how many errors you have. And then we divide by the number of minutes spent typing. Okay, mathematically here, I really don't care about all of that. All I care about is this equation, S is equal to W minus 10E all over M. And I say, okay, I want you to solve for E. Solve for E. Now, this might be one of the most complicated ones that we have because there's a lot going on. But it's not difficult if you just keep taking it step by step. What do you think the first operation should be to get E alone? Solomon's got it. He knows it.
Times M to F.
Exactly. That's tricky. Because it's a fraction, because I've got a big fraction bar, I need to multiply M over to the other side first. S times M is equal to W minus 10E. That's a tricky part about this problem. Because we had that fraction bar, we have to remove the denominator by multiplying it over to the other side. Now we can solve for E. Okay, what's the next step to solve for E? Danielle? Subtract W from both sides. So we've got SM minus W is equal to negative 10E. Still solving for E. Finish it off. What do I do? Divide by negative 10. And everybody gets divided by negative 10, right? SM. Divide by negative 10. Negative divided by negative. I can make that a plus in there. W over 10 is equal to E. Is E alone? Yes. So I'm done. Watch out there. Catch that. We made that negative divided by negative into a positive right in front of the W.
Wait, that was our homework, right?
What?
Look,
It's
it says
on
it.
the board.
Now this is your homework.
No.
Yes. If I didn't give you extra practice, you might not understand this stuff.
I don't know how it works.
Okay.
Oh, I forgot to turn off the video. Remember, bananas, folks, bananas.